Hello, this is the second part of our two-part series in factoring polynomials. If you missed part one, I will link a video in the description below. In part one, we looked at factoring an equation into two quantities using a trial and error method. Today, we will be looking at three rules that may prove useful with factoring simple cases of polynomials of a degree that is larger than 2. And we will also look at factoring by grouping. So let's get straight into it because there's a lot to do. So the first rule we want to look at is called the difference of squares. This rule states that if you have an equation, x squared minus y squared, that will factor down into x plus y multiplied by the quantity x minus y. If you were to multiply the factors together, you will get x squared plus xy minus xy minus y squared. And we see that the opposite signs in the middle terms cancel one another out. And therefore, you're left with x squared minus y squared, which is the exact same thing as our original equation. Now, looking a little more closely at this rule, we see that if we make the original equation match the x squared minus y squared, then we will be able to plug in the value of x and y into our answer. And so what that's saying is we are able to take this value of x and plug it in here, and this value of x and plug it in there. Similarly, we can take this value of y, plug it in here, and this value of y, and plug it in here. So you're not guessing, rather using the material provided in the equation to help you get your answer. Okay, let's look at a few examples. Okay, so we look at our first example. We have 9a squared minus 16. So if we look at our rules for the difference of squares, we know that if we get x squared minus y squared, that's going to factor down into x plus y, x minus y. So what we're trying to do is get this equation into this form. And so we see that 9 and a are both perfect squares. So if we wanted to, we can rewrite this as 3 squared a squared minus 16. Now, we also know that by our rules of exponents, we can do 3a squared minus 16. We also know that 16 is a perfect square, which can be written as 4 squared. And so therefore, this problem can be written as 3a squared minus 4 squared. Well, we now have the exact same thing we have here. So then all we need to do is use this rule and plug in x and y. So again, we have x and we have y, and all we need to do is plug in x here, and we have y, and we need to plug in y here and here. Therefore, this becomes 3a plus 4, 3a minus 4. And that's our answer. Now, if we wanted to check our answer just to make sure that we have the exact same problem, we can multiply these together, and we're going to get 9a squared minus 12a plus 12a minus 16, and that reduces down to 9a squared minus 16, and that matches our original equation that we have, and that means that this answer is correct. This rule and the next two rules make it very easy because we do not have to guess the correct factors or the factor placement or the operation. It's a plug and chug, so it makes it very, very simple. So let's try another problem. Okay, so our next problem, we have 16x to the fourth minus y minus 2u squared. So again, we look at our rule to see if we can manipulate the equation to match. And our rule states that x squared minus y squared equals x plus y, x minus y. So thinking about that, we do see that this is already in a square form for y. And we have our minus sign, which is the same. So our back end of the equation already looks really good. So what we need to do is focus on the front end of the equation. We know 16 breaks down into 4 squared, and x to the 4th breaks down to x squared squared. So with our rules of exponents, we know that we can do 4x squared squared, right? And we already know we have the back end of the equation. And so therefore, following our rules, all we need to do is plug and chug. We have the x value here, which will go here and here. And we have the y value, which is going to go here and here. So let's do that. So we have the 4x squared plus u minus 2u multiplied by 4x squared minus y minus 2u. And that's our answer. Very, very simple. All right, let's move on to our next two rules. Okay, now we're going to look at the difference and the sum of two cubes. These rules are very similar. However, the only difference are the change in the operation. So we see with the difference of the sum of two cubes, we have x cubed minus y cubed, and those factors are going to lead to the quantity x minus y multiplied by the quantity x squared plus xy plus y squared. Similarly, you have the sum of two cubes, and again, the only difference is going to be that operation. You have x cubed plus y cubed, and the factors are going to be x plus y multiplied by the quantity x squared minus xy plus y squared. Now, again, the difference between these are the operations that we see. So here we have a minus and here we have a plus in the difference, and then in the sum we have a plus and we have a minus. Similar to the plug and chug method that we used in the last rule, this rule will allow us to do the exact same thing. We would just need to manipulate or massage the equation that we have into the form that looks just like this. So let's take a look at an example. If we have 125 minus 27 x cubed, we see that this is the difference of two cubes. We know that because we see a minus sign, which tells us it's the difference, and then we also see a cubed here, and we know that 125 is also a cubed value. So that makes sense to use this rule. So looking at it, we know 25 is the cube root of 25 is 5 cubed. 5 times 5 is 25, times 5 is 125. If we do the same thing to the 27, we know that the cubed root of 27 is 3, so 3 times 3 is 9, times 3 is 27, and then we have x cubed. Now, with our law of exponents, we can manipulate this equation to do 3x, and then that quantity cubed. So again, we now know our x value and we know our y value. So all we need to do is plug and chug. And so with that, we have 5 minus 3x, 5 squared, plus 5 times 3x, plus 3x squared. And so now we simplify 5 minus 3x. We have 25 plus 15x plus 9x squared. And that's our answer. Okay, now that we've seen an example with the difference of two cubes, let's look at an example for the sum of two cubes. Okay, looking at our next problem, we have 343 x cubed plus 9y. We see that we have a power that's greater than 2, and we also see that we have two terms. It might make sense to use the sum of two cubes, seeing that we have this positive sign. What we first need to do is to see if we can manipulate this equation into a form that matches that. Well, let's try that. We know that the cubed root of 343 is 7, and we have x cubed. We also know that the cube root of y to the 9th is y to the 3rd, with a 3 out there. With our rules of exponents, we can rewrite this as 7x cubed plus y3 cubed. So now we have this equation matching this form, and therefore we just need to plug and chug. We have this x value, which needs to go into each one of these x's, and we have our y value, which needs to go in each one of these y's. Let's do that. We have 7x plus y cubed multiplied by 7x, that quantity squared, minus 7x multiplied by y cubed plus y cubed squared. Now we need to simplify, and we have 7x plus y cubed multiplied by 49x squared minus 7xy cubed plus y to the 6th. And that's our answer. Again, it's very simple because we were able to manipulate our original equation into one of the rules. From the rules, it becomes a plug and chug. Once you have your plug and chug, you know you're good to go. Okay, so now that we've went over the sum and difference of two cubes, as well as the difference of two cubes, the last factoring technique we will be looking at is factoring by grouping. Similar to everything else we've looked at today, we will be manipulating the equation to turn it into something we are familiar with, and it brings everything together that we've learned from part 1 and part 2 up to this point. So let's take a look at an example. Okay, in our last example, we're going to be looking at factoring by grouping. So, as I said, this brings together everything from part 1 and part 2 thus far. So in part 1, we talked about trial and error, and then in the first part of part 2, we talked about the difference of squares, and then we just went over the sum and the difference of two cubes. So with that, we're going to try to apply as many things as we can to try to factor this problem. But again, with trial and error, you may go down one path and then realize that it's not the correct one. So you have to try a different method and see if you can get the right answer. So let's start this problem. So right off the bat, we can see that we could possibly use a difference in square here, because this factors down to x squared minus 3 squared y squared, which means this could be written as x squared minus 3y squared. And with that, that might be a really good candidate for the difference in squares. And so let's keep going down this path since it looks like it's going to be good. With the difference of squares, we know that we have x plus y and then x minus y. We have our value of x, which is x. We also have our value of y, which is 3y. And then we multiply that by the x minus 3y. And then we still have the rest of the expression 4x plus 4. Okay, let's see what else we can do. We see that this can factor out of 4, so now that leaves us with x plus 3y, x minus 3y, plus 4x plus 1. Now, this is as factored down as this can possibly go. However, this is not correct. And the reason why it's not correct is because typically with factors, it's just a quantity multiplied by a quantity multiplied by a quantity. There are no operations of plus and or minus. It's all multiplication. And because we know this to be true, we know that this is not the correct path to go down. So let's try a different path. That one didn't work. So with that, we can erase all of this work. That's the beauty of trial and error. You try it and then it might not work. So let's see a different path. Let's see if we can rewrite this in a way that we can try to find something else. So we can see that if we bring the 9y squared out in front and rearrange the equation of 4x plus 4, we know that we can factor this out, right? And so with that, let's try to factor. We have 9y squared plus this factors down to x plus 2 and then x plus 2. And we know that if we want to check that work, it would be x squared plus 2x plus 2x plus 4. X squared plus 4x plus 4 gives us the exact same thing we have. So we know that's the correct term. Now what we can do is we see that this and this are both squares. And so if that's the case, maybe we can use the difference in squares. So we have a negative 9y squared plus x plus 2, which is a squared. And now what we need to do is it's the difference of squares, as we know. So it's x squared minus y squared. So we just need to rewrite the equation as x plus 2 squared minus 9y squared. We know that 9 is a perfect square and can be written as 3 squared multiplied by y squared. And so with our rules of exponents, we can actually rewrite this as 3y squared. Now, if we substitute that back in, we have x plus 2 squared minus 3y squared. In this form, we have seen this before, and then we know this is x plus y multiplied by x minus y. So all we need to do is plug and chug. So with that, we have x plus 2, because we know that this is the value of x, and we know that this is the value of y. So that's all we're doing is plugging it in. X plus 2 plus y, which is a 3y, and then we have multiplied by the quantity x, which is x plus 2, and then y minus 3y. And now we have factors that have no addition between them, and therefore we know that this is correct. And if we wanted to check our answer, we can multiply this out and simplify it to get the correct answer. I might be running out of space, but let me try it real quick. So with this, we're going to get x squared plus 2x minus 3xy. And then we're going to get 2x plus 4 minus 6y. And then we're going to get 3xy plus 6y, and then minus 9y squared. So we know that this negative 3xy and this positive 3xy cancel out. We know that the 6y and the negative 6y cancel out. We can also see that these two terms can combine together because they're the exact same. And so with all of that simplified, we're going to get our x squared plus 4x plus 4 minus 9y squared, which is exactly what we have here at the top. So I hope you enjoyed this video and learned a lot. If you did, give it a thumbs up, and we'll see you next time.